Hello, fellow students, and welcome to the class. Today we are going to work on a problem related to the vertex degree. So stick around and enjoy yourselves. And this is the problem for today. It reads like, reason if it's possible a graph like G, right, which is defined by a set of nodes or vertex, a set of links or edges, and an application, right? And we only have this information, that we have three nodes, A, B, and C, and that the degrees, the vertex degrees, are 3 for each of those nodes, right? So the first thing to do is to check out the theory and to see what is the degree of a vertex, right? The vertex degree. So the degree or valency of a vertex of a graph is the number of edges or links, right? It is the same thing, that are incident on the vertex. Incident to the vertex, sorry. So let's try to draw this graph, right? It is an undirected graph. So let's draw. I will take the black color. Right, we have this graph with three nodes, and now let's try to make the degree of these nodes 3, right? So if I start by A, one way to make the degree 3 is to draw 3 links that are incident on this vertex, right? Now I have to do the same for B and C, right? So if I put another link here, now I have that the degree of A is 3, the degree of B is 3, right? I have 3 edges, sorry, that are incident on this vertex. But the degree of C is 2, right? I only have 2 links here. So what happens if I try to increase the degree of C? If I try to draw a new vertex, a new edge here, a new link, so that means that now the degree of C is 3, but the degree of A is 4, right? So it doesn't meet what we are asked for here, right? Because A has a higher degree than 3. What other things could we do? We could put a loop on C, right? Instead of linking these two nodes, we could put a link on 3. And if we do this, we have that the degree of, here the degree of B in the second option what was still 3. We didn't change B. And here is the same, right? We didn't change. With this option, we don't change B. With this third option, we also have only 3 links on A. But now, right, we have 4 edges that are incident on C, right? We have this endpoint, we have this endpoint, we have this one, and we have this one. Remember that now we are not in the case specified by the red line, but we are on the green, right? On the green case. So in this case, the degree for C would be 4, would be also 4. Right, so that means that it is not possible, right? This example is not possible, right? So let's write the answer to this problem. It is not possible. Why? Because the summation of all the nodes of a graph must be the double of the number of edges. The reason is that one edge contributes with 1 unit to the total degree of each one of the vertex in its endpoints. Right, so in conclusion, as the summation must be an even number, and in this exercise, is 9. The graph or such graph is not possible. Right, so this is the answer to this question. Okay, so thank you for joining me on this lecture. If you have any question, please don't hesitate to ask in the comments behind the video. And I will see you in the next videos related to this topic. So bye-bye.